Welcome to some worked examples from the Simple Geometric Theorems assignment. We're going to do 3 examples. Our first one's going to be problem 1 and 2. This one, you're just trying to prove if the segments across from each other are congruent, which would be these two. Well, to complete this proof or disproof, you have to name them. So let's put some names on these endpoints. We got A, B, C, and D. And you'll need to get the distance from A to B. So remember, notation-wise, if you don't put a line over it, that means distance. So to get our distance from A to B, we're going to turn it into a right triangle and count those legs there. We got lengths of 2 and 3. And so it's going to be the square root of 2 squared plus 3 squared. 2 squared plus 3 squared is 4 plus 9, which means the distance from A to B is the square root of 13. Well, let's look over at from C to D. Again, we'll turn this into a right triangle. We got sides of 2 and 3. That's a good sign because those are the same measurements there. But let's make sure and calculate the actual distance, which is going to be 2 squared plus 3 squared again, which is 4 plus 9 inside, so it's the square root of 13 again. So the distance from C to D is 13. And so now we're going to write out the proof. So this is the work, the evidence, and now we're going to write out the proof in a sentence. And so we can write out that AB segment, AB is congruent to segment CD because, and I'm going to be writing a really similar statement here, AB, not AA, equals CD. This says the distance from A to B equals the distance from C to D, and that equals the square root of 13. And that's it. Like, that's the proof. We completed it. We did all the work here, which proves it's the square root of 13 for both. But you do have to have your concluding statement where you bring your evidence together. Segment AB is congruent to segment CD because the distance from A to B equals the distance from C to D, which equals the square root of 13. So some of these can be pretty simple, hence the name of the assignment, and that's okay. We're going to do another one that's on the front there. Is number 7. We're supposed to find the midpoint and prove it's the midpoint. You should look over your line here and see if you can put a point right where you think the center is. Go ahead and try it. Did you put it right here at -2 and -1? Hopefully. Well, if we're going to prove this guy is a midpoint, we need to prove that either side of it is the same length. And so our end goal is to prove that the distance from A to C equals the distance from C to B. Well, let's go ahead and turn these into right triangles and figure out their lengths. So we got the distance from A to C equals, those lengths are 3 and 4. We'll need to square them and add them up. That's distance formula stuff. The distance from A to C is the square root of 9 plus 16, which equals the square root of 25, which equals 5. Nice. All right, well, we also need to get the distance from C to B. Let's change colors here so you can realize it's a different part of this. Turn this into a right triangle. We got side lengths of 3 and 4 again. That's a really good sign because they're supposed to end up being the same. And we'll put that up here. Distance from C to B equals 3 squared. The square root of 3 squared plus 4 squared. And we know that 3 squared plus 4 squared is 9 plus 16 down here. And so it's going to equal the square root of 25, which is going to equal 5. Excellent. So now we have our evidence figured out. Now we're going to write out a statement that lets us know this proof that C is a midpoint. And so we're going to be writing that out. C is the midpoint of segment AB, and that's because the distance from A to C equals the distance from C to B, which equals 5. And now our proof is over. You do need to make sure you have this work on here though, because our proof is referring to that actual distance. So make sure you have it on there. That's the work that proves that distance from A to C is the same as distance from C to B, which is 5. We're going to do one more example, and this one's from the back. And we're going to be proving whether or not this is a right triangle. Well, the thing that's special about right triangles is that they have a right angle. And to prove something has a right angle, you'll need to figure out the slopes of the sides where you think it hits at a right angle. So let's look at our angles and decide which one of these could possibly be the right angle. This one up here at S is not looking promising. T also not so much right angle. R is looking like the most promising prospect for where the right angle is going to be. And that'll mean we need to figure out if these slopes here are opposite reciprocal slopes. That's from our previous lesson. If two lines are perpendicular, they have opposite reciprocal slopes. And so what we're going to do is get the slope of RS. And, you can draw your little right triangle, and it goes up 3 and right 3, which means our slope is 3 over 3, which is just 1. Awesome. Well, we also need to get our slope from R to T. Well, you're going to, again, draw your little right triangle here. It's going down 2 and right 2. So it needs to go down 2 and right 2. Remember, if it's going down, it needs to go right. It's a negative slope. Negative 2 over 2 is negative 1. And now you need to decide if these are opposite reciprocal slopes. Hopefully you realize they're opposite reciprocal slopes, because they are. And so that would mean that these two segments are perpendicular right there. And so we're going to write out our proof, which is pretty simple here, but it's going to take some different language than our last one. And so we can write out that RS, segment RS, is perpendicular to segment RT. So yeah, this means perpendicular to, and that's just a symbol for it. It's two perpendicular lines or an upside down T. Because, and you need to say why, they have opposite reciprocal slopes. That's a terrible C. Reciprocal slopes. And we needed to prove it was a right triangle. And so we can write out that triangle RST is a right triangle because RS is perpendicular to RT. Awesome. So there's our proof. And there's your 3 examples. Good luck with the rest of the assignment.